Today we're going to look at the surface area and volume of pyramids. And so we've talked about prisms in the past, and these are very similar to prisms except they just have one base. So a prism would be similar to this except it had a base on top. Here it has one base and all of the lateral faces meet at the top here. So the instructions say draw the net for the shape below and then find the surface area and volume of this pyramid. So on the next slide here I have the net drawn out, and before I get to that, what's going to happen is all four of these sides, just imagine me kind of taking a scissors and clipping the top of this, all four sides are going to fall down. So you can have a square with four triangles. It's going to look something like this. Okay, so now let's label our net. This is our flat surface, and if we look back on this one, this is a square bottom, so this is 10, and then this is also 10, and then 10 and 10. So let's label it. Here's 10. This is 10. This is 10. And this is 10. Now, what goes here on the dotted lines? And then do we put something on these lines as well? So let's look back at our 3D shape here. When we clip this, what ends up happening, the walls fall down and it becomes flat. It's no longer 12 tall. So the temptation is to write 12 for the height of the triangle, but 12 disappears when you draw the net. So this diagonal line here, this is called the slant height. So we'll kind of label that as the slant height. That's just the term we use for that. And usually the symbol that's used for that is cursive L. So slant height we call L. And this slant height is what's going to go on our net for the height of the triangles here. Okay, so we don't know that. We got to do some math to figure that out. Okay, what I do notice is, I'm going to switch colors here. I'm going to highlight this in red, is I've got a triangle that goes from here over and then up and then down. So I have a right triangle. There's a 90-degree angle right here. And I know this side is 12. This side is 5. It's halfway across the whole thing, which is 10. And so to figure out this side, we're going to have to use the Pythagorean Theorem. So we'll go a squared plus b squared equals c squared. In this case, a is 5, b is 12, and c is what we're figuring out. So 5 squared plus 12 squared equals c squared. 5 squared is 25. 12 squared is 144. So we add these two together, we get 169. And then we square root both sides, and we get the square root of 169 is 13. So that means that this side here is 13 units long. Okay, so let's go back to our net, and we're going to label all of these as 13. So 13 here, 13 here, 13 here, and 13 here. So we don't really need this side. If you want to find that out, you definitely could do that. It'd be 5 squared plus 13 squared equals c squared, and that would give you this. But if we're trying to find the surface area, all we need for each of these triangles is the base and the height. And the base is 10 and the height is 13. Okay, so let's figure out the surface area. We drew the net. I'll do the surface area in green. So for this square here, this is 10 by 10. So to find the area of that, we just go 10 times 10. So 10 times 10 is 100. Okay, for each triangle, we do the base times the height, and then divided by 2. So we're going to go 10 times 13, and then divided by 2. So 10 times 13 is 130. 130 divided by 2 is 65. So the area of this triangle would be 65. The area of this triangle is 65. The area of this triangle is 65. And the area of this triangle is 65. So now that we have all of the areas of all the parts, surface area, we're just going to add up all the parts together. So we'll take 65 plus 65 plus 65 plus 65 plus 100. So the surface area is 65 times 4, because there's 4 of those, and then plus 100. So this is 260 and 100, so the surface area is 360 units squared. All right, so we got the surface area done, and then I believe the question asked us, it said find the surface area and the volume. Before we move on to the volume, just want to refresh your memory. If it asks, on one of your questions, it asks for the area of the base. So area of the base, that's going to be the 100. And then if it asks for the lateral area, that's all these 65s added together. So 65 plus 65 plus 65 plus 65, that's the stuff that's not the base. So that we figured out was 260. Okay? Units squared. Okay, so the volume. The formula for this is just like a prism, except it's area of the base times height divided by 3. And one of the cool things that I really enjoy doing in my class is I take a pyramid that has the exact same height as the prism and the same base dimensions, and we look at how many of these fit inside of the prism that's the same height. And if you take and fill this up with water and dump it into a prism that is 12 tall with a base that's 10 by 10, exactly 3 of these will fit inside that prism. Okay, so we're not dealing with a prism, we're dealing with a pyramid, but you still do the area of the base times the height, and then once you get your answer, you just divide by 3. So the area of the base we figured out was 100. The height here is 12. And then we take that answer and divide by 3. So we get 1,200 divided by 3. So the volume is 400 units cubed. All right, and that's it. So that's the surface area and volume of a pyramid.